Hello students, welcome to one more amazing session for you. Today we discuss lecture 2 of class 11th mathematics. In this lecture we discuss different kinds of sets with proper examples. I hope that you will enjoy this session also. Let's get into the session. Let's get into the session. Now, last class we have discussed what is set and how we represent sets in two different forms, set builder form and roster form. Now, today we discuss different types of sets. Today we discuss different types of sets. Lecture number 2 of class 11 mathematics. Chapter name Basics of Maths. Their topic is sets we are discussing. Now, today we discuss different kinds of sets. What is first one is empty set. What is meant by empty set? A set which does not contain any element is called the empty set or null set or void set. A set which does not contain any element is called the empty set or null set or void set. It is denoted by phi or empty curly brackets. It is denoted by phi or empty curly brackets. Examples: the collection of all natural numbers less than 1, it is empty set. Why? Because natural numbers are starting from 1 itself only, 1, 2, 3 and so on. This is called set of natural numbers. Less than 1 means there is no any natural number. So, number of elements is 0. There is no any element containing this set. So, this is called empty set. And second example, A equals to set of x such that 2x plus 11 equals to 12 and x belongs to natural number. This representation of a set is set builder form. In this set builder form, you can find the values of x under the given condition, that is 2x plus 11 equals to 12, indicates 2x equals to 12 minus 11, 1, x equals to 1 by 2, which is not a natural number. So this set also contains no element, so that this set is also called empty set. These are the examples for empty set, a set which does not contain not even single element. Collection of all natural numbers less than 1, or A equals set of x such that 2x plus 11 equals to 12, x belongs to natural number. These are examples for empty set. The second kind of set, it is called singleton set. What is meant by singleton set? A set that contains only one element is called a singleton set or unit set. A set that contains only one element is called a singleton set or unit set. Examples: A equals to set of 2024. So this set A contains only one element, which is 2024, so that it is called a singleton set. And example 2, set builder form, that is x set of x such that 2x plus 11 equals to 13 and moreover x belongs to natural number. If you solve this equation, 2x equals to 13 minus 11, that is 2, then x equals to 1, it is first natural number. So, for example, if you take the set as B, then same we can represent in tabular form or roster form. B equals to set of 1. So that this set is called singleton set because this set contains a single element which is 1 only. One important point we have to remember here, that is phi. Already we know phi is representing null set, but set of phi is a singleton set. If we write the phi like this, it is called symbol for representing a null set, but in the set, if you write 5, set contains one element, so that this is called singleton set. 5 is null set, but set of 5 is a singleton set. And third one is finite set. What is meant by finite set? A set that contains a finite number of different elements. A set that contains a finite number of different elements is called a finite set. Finite number of different elements. For example, A equals to set of A, B, C, D. This is a set A which contains 4 elements A, comma, B, comma, C, comma, D. So that this set A is called a finite set because it contains a finite means countable number of elements. Means countable number of elements A, comma, B, comma, C, comma, D. Similarly, in the set builder form, B equals to set of X such that X is a month in a year. X is a month in a year. Then, if you write this one in tabular or roster form, month in a year means January month, February month, March month, April, May, June, July, August, September, October, November, and December. So, this set contains 12 elements because in a year we have 12 months are there. So, that B equals to set of X such that X is a month in a year is also called a finite set. Similarly, suppose C equals set of X such that X is a day in a week, then that is also a finite set because days means Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. It contains 7 elements. Now, fourth one, infinite set. A set that contains unlimited number of different elements. A set that contains unlimited number of different elements is called infinite set. Uncountable number of elements is required for infinite set. Now, examples for infinite set, the set of all natural numbers is called infinite set, set of all whole numbers, set of all integers, set of all rational numbers, set of all irrational numbers. All these sets are called infinite sets because each of these sets contains infinitely many elements. Okay. Now, one more example, the set of all points in a line, because line means joining from line has no end points. All these are called the points on a line. So that this is also called infinite set. This is also called infinite set. Okay. First one is empty set, a set which does not contain any element. Singleton set, only one element. Finite set, countable number of elements. Infinite set, uncountable number of elements. And order or cardinal number of a set. This is important point. Order or cardinal number. What is meant by order or cardinal number? The number of different elements in a finite set capital A is called the order or cardinal number of A, denoted by n of A or order of A or mod A. These are the different ways we can represent number of elements in the given set. The number of different elements in a finite set. Here, one important point, different elements. The element should be different. That is called order or cardinal number. Example, if A equals to set of A, E, I, O, U, vowel in English alphabet, how many elements that this set A contains? 1, 2, 3, 4, 5. So that n of A equals to 5. This set A contains 5 different elements. So n of A is 5. And one more, B is the set of the letters of the word college. B is the set of the words, the set of the letters of the word college. B is the set of the letters of the word college. Then we can write this set in the set tabular form. The elements in the set are C is one element, O is one element, L is one element, E is one element, G is one more element. This set B contains how many different letters? Those are 5 only. So that N of B equals to 5. Here one note point is important. It is sufficient to write each element in a set only once. If one element is repeated twice or thrice, it is not required to represent all those times in the set. One time is enough for writing these elements in the set. So B, actually COLLEGE, total number of letters 7, in which L is repeated twice and E is repeated twice, but number of different elements only count in order or cardinal number. So that number of different elements in the set B equals to 5. So that order of set B or cardinal number of set B is 5. Now come to one more concept, analysis of two sets. Analysis of two sets. Here we discuss equal sets and equivalent sets. What are said to be equal sets? Two sets A and B are said to be equal if they have exactly the same elements. They have exactly the same elements. That is, A equals to B. Example, see, A equals set of 1, 2, 3, B equals set of 3, 1, 2, C equals set of 1, 2, 2, 3, 3, 3. Then A, B, C, all three are same sets because in the set theory, order of the elements is not a matter in set theory. Set A contains the elements 1, 2, 3. Set B contains same elements 1, 2, 3, but they are in different order. We write in the set B, but you can write in any way. There is no any issue. So that A contains, B contains same elements, whereas C 1, 2, 2, 3, 3, 3. 2 repeated twice, 3 repeated thrice, it is not required. In set theory, already we have discussed C is same as 1, 2, 3 only. Because 2 repeated twice, but there is no any validity for writing one more 2. And similarly, 3 is also one time is enough. So set A contains 1, 2, 3, set B contains 1, 2, 3, set C contains 1, 2, 3. All the three sets are equal sets. Next, second one is equivalent sets. Equivalent sets. Two finite sets are said to be equivalent if they have same number of elements. Means order or cardinal number of those two sets are same. The sets not necessarily exactly same. Two finite sets are said to be equivalent if they have same number of elements. If two finite sets A and B are equivalent, then n of A equals to n of B is enough. Number of elements in set A, number of elements in set B must be same. We write it by A is similar to B, means A is equivalent to B, or A is double equivalent to B. N of A equals to N of B, then the two sets are said to be equivalent sets. Here one important point, equal sets are equivalent, but equivalent sets not necessary equal sets. Equal sets are equivalent, but equivalent sets are not necessary equal sets. That is, suppose A equals set of 1, 2, 3, B equals set of X, Y, Z. A and B are not equal. Here A is not equals to B. Here A is not equals to B. But N of A equals to 3 and N of B is also 3. So that N of A equals to N of B. These two sets are equivalent sets but not equal sets. Similarly, one more example, A equals to set of X such that X is a letter of the word FOWL, then A can be written as set of FOWL, foul, and B equals to set of X such that X is a letter of the word wolf. Then the set is WOLF. Then F is there in both the sets. O is also there. L is also there. W is also there. So here N of A equals to N of B equals to 4 and A equals to 4. These sets A and B are both equal and equivalent sets. That's today's class. Next class, we will discuss what is subset and power set, subset, power set, proper subset, and Venn diagrams, operations on sets. We will discuss in the next video or next class, which is class number 3. Now, I end this session. I hope all of you enjoy this session. Thank you, one and all.